So hopefully one of the things that we've taken out of the first couple videos is that standard form is awfully nice to work with when it comes to a circle. Unfortunately, I'm not a very nice person, which is why I'm not always going to give you standard form for a circle. On occasion, I'm going to give you general form of a circle. General form of a circle is where your squares are not completed, rather they've been expanded, and that you have a zero on one side of the equation. So general form of a circle is considerably less handy than standard form. Now, just to give you an example of how you would go from standard form to general form, let's say I give you a circle like x plus 1 quantity squared plus y minus 3 quantity squared is equal to 4. So standard form of a circle, we can see that the center is at -1, +3, and that this would have a radius of 2. If I were to expand both of these completely by expanding the binomial, more commonly known as FOIL, I could change the x plus 1 quantity squared into x squared plus 2x plus 1. Y minus 3 quantity squared would become y squared minus 6y plus 9. That's all equal to 4. So I've gotten rid of my completed squares on the left-hand side. Now I need to get a 0 on the other side, and I'll do so by subtracting 4 from both sides of the equation. After I combine all of my like terms and maybe do a little bit of reordering, we'll have an x squared, we'll have a y squared, we'll have a plus 2x, we'll have a minus 6y, and then 1 plus 9 minus 4 would be plus 6. This would be general form of a circle. Now, taking a look at the general form, I cannot tell you just by looking at this what the center is, what the radius is. Rather, if I wanted to go from general form back into standard form, I would have to complete the square. So that would be to go from general to standard form. Now, that's not exactly true. It's actually twice as much fun as completing the square once, because you have to complete the square twice. You have to do it once for the x variables and once for the y variables. So an example of one such problem here is sort of general form of a circle. So no completed squares, we got a 0 on one side. This would be an example of something that is general form. So what I'd like to do with this is first convert to standard form. Now, one thing that I notice about this particular circle is that both the x squared and the y squared now have a coefficient attached to them. Generally, that's not something that we would look for in standard form or to complete the square. So what I'm going to do is divide both sides by 3 to go ahead and clear that out. So the 3x squared would become x squared, 3y squared would become y squared, minus 6x would become minus 2x, and plus 12y would become plus 4y. Now I'm going to do a little bit of reordering so that we can sort of get things in the proper order for purposes of completing the square. I want to put my x term right after my x squared term, and I want to put my y term right after my y squared term. Now, if I had a constant term, I would put that over on the right-hand side, but for now we'll just toss a 0 into that position. So the process of completing the square says take this number, that is the coefficient of your first power term. We are going to divide that by 2 and square the result. Now, when I divide by 2, I'll get -1. When I square the result, I'll get +1, which means that a +1 is going to complete the square. Now, anytime you complete the square, though, you have to balance out that +1 by either adding it to the other side or by subtracting it from the same side, a strategy that we'll see more in the conic sections. So same thing for this one. We divide by 2, we square the result. Result is 4. So a 4 is going to complete the square for the y terms. I'll get a +4 over here as well. Now that means that x squared minus 2x plus 1 can now be factored as a completed square. Specifically, that would be x minus 1 quantity squared. For the y terms, we have y squared plus 4y plus 4 that completed square would be y plus 2, quantity squared. That's all equal to, on the right-hand side, 5. Now, by converting to standard form, it makes it a lot easier to do any of the things that we would have done in previous problems. For example, we could say find the center and radius. To find the center and the radius, we take a look inside each of the parentheses and say that the center is going to be whatever's being subtracted from each of our variables. For x minus 1, that gives us a positive 1. For y plus 2, that's going to give us a negative 2. As far as the radius is concerned, that 5 is referring to r squared. So we take the square root of that and we get our radius. No need for a plus or minus. A radius is referring to a distance. So that radius will be the square root of 5. Then if I wanted to do other things like graph the circle or find its intercepts, I could certainly do that as well.